In this session, I am going to teach you about the concept of cells, EMF and internal resistance. First, I will go with the basics of a cell. So, what is the current? I told you before. Current is a flow of electrons. Okay. For something to be flow from one point to another point, we need a difference in the value. That is, for a water flow, we need a difference in head of the water. That is the difference in pressure. Similarly, when we take any charges, for the charges to flow from one point to another point, we need the difference in potential of the charges. Okay, here I take an electrolytic cell. So we deal with the concept of cell. What is a cell? How does the current flows through a cell? Okay, the electrolytic cell concept. Now I will show you an arrangement. This is an arrangement. Okay, here I have inverse here. I am taking an electrolytic solution. This is an electrolytic solution because what is an electrolyte? An electrolyte is a solution that dissolves. Okay, that has cations and anions. Okay, initially it will be in a neutral state. Initially it will be in a neutral state. For example, water is an electrolyte. Then if you add some sodium chloride in the water, okay, it gets dissolved in it. And if you give any other potential to that solution, okay, the potential means what? The positive and negative charges. The solution itself will get dissociated into positive and negative ions. The solution will get dissociated into positive and negative ions separately when you give potential to that solution. Yeah. Now, so ஒரு செல்ல ஒரு பேட்டரி எடுத்துங்க. பேட்டரி பாசிட்டிவ் இருக்கு நெகட்டிவ் இருக்கு. இப்படி சொன்னா உங்களுக்கு கன்வீனியன்ட்டா இருக்கும். ஒரு எலக்ட்ரோலைட்டிக் சொல்றது. There is a solution. I have an electrolytic solution. இது ஒரு standard diagram. You follow this standard diagram in your exam. This is for your understanding and drawing. This is an electrolytic solution. I am now taking a rod from here and digging here. ஒரு rod எடுத்து dig பண்றேன். So initially in the electrolytic solution, this is the solution. Initially this is a solution which is neutral in state. The positive and negative ions move agadu. There will be any movement. And you see when you take a positive and negative polarity cell, ஒரு பேட்டரி எடுத்து, okay, இதுல பாசிட்டிவ் எடுத்தீங்க ஒரு பாயிண்ட்லயும் நெகட்டிவ் எடுத்து ஒரு பாயிண்ட்லயும் இன்வெஸ்ட் பண்ணா அது then what happens? எல்லா பாசிட்டிவ் நெகட்டிவ் irrespective of the polarity it has its own potential. அதுக்கு ஒரு ஸ்ட்ரெngth இருக்கு. So positive can be given V plus, that is V minus. Charge in the negative or polarity is given as negative. Okay. So what happens here is negative of V and that is V plus. In the point fullave ipenna V plus avadhu. In the point fulla V minus. Cathode na enna anode na enna theriyuma? You should be very familiar with the words cathode, anode, cation, anion. There is a big chemistry behind this. Actually, your chemistry background another you will understand very well. Okay, there is a big chemistry behind this. So, but I will tell you simple. Cathode and another, it is a junction with, that is a negative terminal. We call it as a cathode. Positive terminal we call it as a anode. For cell or negative terminal, what we call it as cathode. Positive terminal we call it as anode. Then, what is a cation? Cation means the charge of that is the ion which has a positive charge. Some majority of the students would have mistaken that cathode and cation. In a ரெண்டுமே cation இது cathode ரெண்டுமே ஒரே ஸ்பெல்லிங்ல இருக்கு ஸ்டார்டிங். அப்ப இது நெகட்டிவ் சைடுனா இது நெகட்டிவா தான் இருக்கணும். There may be some misconceptions like that. It is not that cation. The charge of a cation is a positive. Cation refers to the positive charge and anion refers to the negative charge. So this cation will be, this is positive and this is negative. The cation will be moving towards the cathode and anion will be moving towards the anode. Because the charge of the cathode is negative, the charge of the cation is positive. Cathode is a negative rod. Cation is a positive charge. Positive charge is negative phase putting move. Negative charge or positive phase putting move. Okay? So the anode will pull the anions. The cation will pull the cations of positive charge. Yeah, this is very clear. Now, here, for p-type and n-type junctions. P-type is positive, n-type is negative. So you take this P and N. Casually, one battery எடுத்து ஒரு LED யோட positive and negative connect பண்ணா, we find that bulb is glowing. Why we go for the study? Because we realize that the current is flowing from positive to negative. That we can visualize when we find that LED is glowing. Here, why this study is, we are studying about the cell. What is a cell? What is the concept that makes the electrons to flow? Here, for spontaneous flow of electrons, spontaneous means continuity of electron flow. Is that right? இப்போ இங்க கேத்தோட this is anode, positive charge on anode. இதோட charge plus, that is minus B. The total charge of this will be denoted as E equal to B plus minus, that is the potential difference. In the point the potential difference in B plus minus B, that is B plus B minus. Okay, that is the potential difference. It is denoted by E, or the electromotive force, or the potential difference. This is a DC, this is a direct cell concept. AC கிடையாது, this is a DC. ஒரு positive side ஒரு negative side. அதான் direct current flow ஆகுதுன்னு சொல்றோம். Okay, நம்ம வீட்டு plug point ல வரது எல்லாமே என்னது AC alternating current. ஒரு battery எடுத்துக்கிட்டாமே அது எல்லாமே DC தான், direct current. So here you see the electromotive force. Here it is considered as a potential difference, not a force. This is not a force. It is just a potential difference. இங்க இருக்கிற எலக்ட்ரானோட அளவுக்கும் இங்க இருக்கிற எலக்ட்ரானோட அளவுக்கும் difference இருக்கு. அதனால electrons flow ஆகும். Okay, you take now. So when this point is immersed here, immersement we are putting into the solution. When this rod, positive rod is put into the solution and negative rod is put into the solution, this will attract this is positive. This will attract the anions here. Anions and the negative charges. The negative charges will not electricity on them. This terminal will attract the positive terminal. Okay? Cations. This immerse பண்ணோம்னா இதை நாம இந்த நெகட்டிவ் anions என்ன பண்றோம்? Cation, this negative terminal will attract. This is a cathode, will attract the cations. Cations are charged positive. This anode will attract the anions. So that is the negative charges. Inge negative பண்ணோம்னா, okay, you assume that the same thing happens here. Negative, positive. So இது ஃபுல்லாவே ஒரு சொல்யூஷன் தான். இதுல உங்களுக்கு நிறைய anions cations எல்லாமே இருக்கு, கண்டினியூஸா இருக்கு. So நீங்க யூஸ் பண்ற பேட்டரிக்கு பவர் எந்த அளவுக்கு இருக்குன்னா இத அட்டாக் பண்ற அளவுக்கு பவர் இருக்கு. அந்த மாதிரி ஒரு குவாலிட்டியான பேட்டரி யூஸ் பண்ணுங்க. நம்ம UPS battery சொல்றோம்ல, we are telling that our UPS battery, that is the concept of here. Our UPS battery is completely charged with an electrolytic solution. Okay, then அப்போ அதை discharge பண்ணும்போது என்ன பண்ணோம், ஒரு சப்ளைல கனெக்ட் பண்ணோம்னா அதுல இருக்கிற கேஷன்ஸ் எல்லாமே கேஷன்ஸ் அயன்ஸ்லாம் ஸ்ப்ரெட் ஆகி உங்களுக்கு circuit close ஆகுது, கரண்ட் வரும். Now when the current will start flowing, the electrons will start flowing because this positive will attract the electrons. Okay, this negative this positive will attract this electrons. This negative side la, negative side la electrons enna attract ஆகி வரும். அப்ப current will flow ஆகும். இங்க பாசிட்டிவ் இங்க எலக்ட்ரான்ஸ் அட்ராக்ட் பண்ணும். ஓகே, இங்க தீர என்ன ஆகும், இதுக்குள்ள சார்ஜ் ட்ரான்ஸ்ஃபர் நடக்கும். இது ஜங்ஷன் A, இது ஜங்ஷன் B ன்னு வெச்சுக்கோங்க. ஓகே, so when there is a lag of this electrons, there is a transfer of electrons from this point. இந்த பாயிண்ட்க்குமே பொட்டன்ஷியல் டிஃபரன்ஸ் இருக்கு. ஒரே தண்ணி தான் ஆனா வெவ்வேறு பாயிண்ட், ஒரே தண்ணி தான் ஆனா வெவ்வேறு பாயிண்ட்ல இருக்கு. அப்ப இந்த பாயிண்ட்க்குமே ஒரு பொட்டன்ஷியல் டிஃபரன்ஸ் இருக்கு. இங்க இருக்கிற சார்ஜஸ்க்கும் இங்க இருக்கிற சார்ஜஸ்க்கும் there is a difference in potential. So there is a, that we call it as a internal, okay, that we call it as a internal resistance. And the internal resistance concept என்ன அப்படின்னா, ஒரே சொல்யூஷனுக்குள்ள that is inside a same solution between some other points there will be a difference in potential. There will be a difference in potential. Very best example, when you are heating a water, the temperature at the top surface and the temperature at the bottom surface of the water is quite different. That you can realize. So that means it is the temperature is not immediately or equally distributed or raised at all the points of the object at the same time. தண்ணில எல்லா பக்கமே ஒரே டெம்பரேச்சர் ஒரே டைம்ல இன்கிரீஸ் ஆகும். Clear? So here the quantity of cations and anions are distributed and there is a difference in potential. So வெளியில இருக்கிற potential difference என்னது, இந்த பாயிண்ட்ல இந்த பாயிண்ட்ல இருக்கிறது V plus minus of minus V minus, இது ரெண்டையும் சேர்த்து எனக்கு V plus V minus வரும். So this is the outer potential difference. ஒரு பேட்டரியோட potential difference எப்படி ரெப்ரசன்ட் பண்ணலாம். Okay, so that is V plus, this is V plus V minus. Okay, now 1.5 volt battery, 5 volt battery, 15 volt battery na இப்படி சொல்லலாம். E equal to 15 volt battery. 15 volt என்னது, இது ரெண்டையும் சேர்த்து எனக்கு இதோட டிஃபரன்ஸ் தான் என்னது 15 volt வரும். சரியா? now இதுக்குள்ள போறனால இந்த சொல்யூஷன் கூட நான் வைக்கிறேன். ஏன் இந்த கான்செப்ட் படிக்கிறோம்னா, ஒரு சொல்யூஷனுக்குள்ள சார்ஜ் ட்ரான்ஸ்ஃபர் எப்படி நடக்குது, இன்டர்னல் ரெசிஸ்டன்ஸ் வார்த்தைக்கு மீனிங் என்ன, வாட் இஸ் தி மீனிங் ஃபார் திஸ் இன்டர்னல் ரெசிஸ்டன்ஸ் அப்படிங்கிற ஒரு மீனிங் தெரிஞ்சுக்கிறா இதை படிக்கணும். ஸோ இன்டர்னல் ரெசிஸ்டன்ஸ்னா என்னன்னா, இப்போ இதே சொல்யூஷனுக்குள்ள கரண்ட் ஃப்ளோ ஆகுதுன்னா, கரண்ட் ஃப்ளோ ஆனா என்ன ஆகும்னு சொல்லியிருக்கேன். வாட் ஐ ஹேவ் டோல்ட் யூ, whenever there is a flow of current there is a drop in voltage. Also each and every material has its own resistance. I told you before, எந்த ஒரு மெட்டீரியலும் நான் சரி அது சாலிடாவும் இருக்கலாம் லிக்விடாவும் இருக்கலாம். why not a gas really having it? Okay, so it has its own resistance. Not all, no material provides 100% what conductivity. 100% conductivity சொல்ல முடியாது, கொஞ்சமாவது ரெசிஸ்டன்ஸ் இருக்கதான் செய்யும். ஸோ இப்போ இது ஒரு லிக்விட் தானே, இது என்ன பண்ணும், கொஞ்சோண்டு ரெசிஸ்டன்ஸ் இருக்கு. it also has its own resistance value. எல்லா சார்ஜஸையும் இமிடியேட்டா ட்ரான்ஸ்ஃபர் பண்ணாது இங்க இருக்கு. ஓகே, it also has a path to flow. இதுக்கும் இங்க இருந்து இந்த பாயிண்ட்ல இருந்து இந்த பாயிண்ட் போறதுக்கு தண்ணியோடவே ஒரு பாத் வேணும். நீங்க எப்படி ஒரு சாக் பீஸ் எடுத்து, இது ஒரு மெட்டீரியல்னா the electron flowing from this point to this point has to travel all the atoms and molecules inside this material. Similarly, this material, the material consider panna, you consider this as a solution. This solution, the charges flowing from this point to this point will flow through all the atoms and molecules in this. Okay, அதில் atoms and molecules சொல்லுறேன்னா ions சொல்லலாம். அந்த பாத்ல போற எல்லா ionsையும் கிராஸ் பண்ணி தான் போகும். So அதுக்கு ஒரு ரெசிஸ்டன்ஸ் இருக்கு. So that we call it as a internal resistance that will be denoted by R. Internal resistance. This internal resistance. Okay. The drop in internal, whenever there is a flow of current, I told you there is a drop in that section. What is a drop here? Because the current I is flowing. You take the current I is flowing. The same current is coming. A series of current I is. Adhe current is there. திரும்பி இந்த கேப் என்ன ஆகுது? அந்த எலக்ட்ரோலைட்டிக் சொல்யூஷன்ல ஃப்ளோ ஆகுது. இங்க வயர்ல ஃப்ளோ ஆகுது, ரெசிஸ்டர் again in the wire, then there is a transfer to this solution. இதையே நீங்க எப்படி பார்க்கணும்னா ஒரு ரெசிஸ்டரா தான் பார்க்கணும். இந்த ஜங்ஷன்ல கிராஸ் ஆகும்போது ஒரு ரெசிஸ்டர் மாதிரி தான் பார்க்கணும். ஏன்னா இது கிராஸ் ஆகுதுன்னா it is traveling, the charges are traveling from this point to this point. அதே சமயம் பாயிண்ட் AB ங்கிறது ஒரு வோல்டேஜ் டிராப் இருக்கு. ஏன்னா அந்த ரெசிஸ்டன்ஸ் வேல்யூ இருந்துச்சுனாலே அதுல கரண்ட் ஃப்ளோ ஆச்சுன்னா அங்க ஒரு வோல்டேஜ் டிராப் இருக்க தான் செய்யும். Because we find the junction A and B. Due to the potential difference, the current is flowing. When there is a flow of current from two junctions, there will be a voltage drop due to the resistivity of these points. Okay, due to the resistivity of the path. Okay, so that is internal resistance of the drop is I into R. This we call it as a voltage drop. Now VAB. And the solution la irukra voltage drop வந்து VAB. That is the internal resistance drop. So அப்ப உங்களுக்கு சப்ளைல வெளியில வரதுக்கு உள்ள டிராப் ஆகுறது போக வெளியில நமக்கு சப்ளை கிடைக்கும். ஒரு UPS பேட்டரி எடுத்தீங்கனாலே நமக்கு வெளியில வர வோல்டேஜ் என்னன்னா உள்ள சொல்யூஷன்ல கொஞ்சம் டிராப் பண்ணதான் செய்யும். We have some losses. அதுக்கு losses னு சொல்லலாம். So previously என்ன சொன்னேன், மேட்டூர்ல உங்களுக்கு பவர் ஜெனரேட் பண்ணாலும் டிரான்ஸ்மிஷன் லைன்ல நிறைய லாசஸ் இருக்கும். அது போக தான் நமக்கு இங்க கிடைக்கும். அது இங்க வந்து ஸ்டேஷன் வேணும் என்ன ஆம்ப்ளிஃபை பண்ணி தான் நமக்கு வேணுங்கிற அளவு கொடுப்பாங்க. So here you say the internal resistance, due to the internal resistance of the solution, there is a voltage drop. So the total voltage, so E is a V. So what you get the total voltage V across if the resistance R illana, the voltage across the C is, if R is infinite, அதாவது open circuit ல என்ன open circuit ங்கற வேர்ட் I am now introducing. Open circuit ல நான் எந்த லோடுமே நான் கொடுக்கவே இல்லை. It means the circuit is open. இப்போ உங்க plug point open circuit தான் இருக்கும். நீங்க எதுமே charging appliances எதுமே அத கனெக்டே பண்ணல. If you do not give any load to your circuit, the circuit is open. Facing neutral நீ கனெக்ட் பண்ணவே இல்லை. That is called as open circuit. Another way is it is of infinite resistance. Infinite na the resistance value is very high, so that it will not allow any current to flow into it. So another way of representing is an infinite resistance load. ஒரு லோட கனெக்ட் பண்ணிருக்கேன், ஆனா அதுக்கு infinite resistance இருக்கு. இல்லாட்டி அது ஓபன் சர்க்யூட்னே சொல்லுவோம். So if you consider this R is not there, if this resistance is not there, what will be there? These two points are open. So the current will not flow from this point to this point. But you have the voltage. You can check whether what is the voltage difference between these two points. The V plus V minus IR. Okay. There is a drop occurs here. In the voltage, source voltage is up. Adhu poga எனக்கு வெளிய எவ்வளவு கிடைக்கும்? இதுல டிராப் ஆகுறது போக தான் கிடைக்கும். ஓகே, இதுல ஒரு டிராப் ஆகுறது வெளிய கிடைக்கும். இந்த பாயிண்ட்ல தான் நம்ம சோர்ஸ் எடுக்கணும். ஓகே. So that is V is V minus IR. இது வந்து ஸ்மால் as a small e. Okay. Now, when you connect a resistance here, what happens when you connect a resistance here? The current will flow here. If I connect a resistance here, the current will flow in this resistor. Okay. So now I is what is V equal to E times E minus IR. So as per the Ohm's law, what is the voltage drop across this? V equal to I times R. So 1 and 2. Now I relate equating 1 because both are V and V. Both are the voltages V and V. I can equate the relation 1 and 2. I can relate the equations 1 and 2. So IR equals E minus IR. So IR is what is the internal resistance? The internal resistance is denoted by small IR. Small r. So use the small r for the internal resistance. Do not use capital R. Yeah. So I into R plus R is E. So I is so that is the final formula here. That is small e. It represents the electromotive force or the potential difference. Questions if you are given as the electromotive force or the potential difference, you can use this E symbol formula. E க்கு பதிலா VU யூஸ் பண்ணா, capital V யூஸ் பண்ணா. Okay, so no confusion in it because this E is applicable only for this. Okay, இங்கே potential difference across this point and this point is the end solid. Okay, specific up. So you pause the video and you better write it in sequence. So please remember this carefully. Don't misunderstand the cathode diagram. This is very important. So then what is the maximum value of the current that can flow through the electrolytic solution if R is 0, if the capital R is 0? Okay, on the expression this is the final expression, that is I is E by R plus R. If R is 0, so the maximum current that can flow is I max is so you have a theory here. The maximum current that can flow through the solution is if R is 0. R 0 on the maximum ever current flow over. Compared to this, R 0 panita, R the dominant point. So this is the maximum current that can flow through the electrolytic cell and provided for safety of the electrolytic cell, the current values will not be allowed to exceed this maximum. அதோட வேல்யூ பாத்தீங்கன்னா இந்த மேக்ஸிமம் ஐமாக்ஸ் குள்ள தான் வச்சிருப்பாங்க எப்பவுமே. அதுக்கு மேல போவானா அந்த பேட்டரி செல் வந்து வீணா போயிடும். That will cause damage to the cell if the maximum value of the current is exceeding the value Imax. Okay, so always it will be less than this Imax only. அது நேராவே விட மாட்டாங்க. Kindly make a note of your doubts while you are listening to the video. In some places Okay, entire point these concepts are new to you, and you may know you may not know how to relate the concepts. Those engeಲ್ಲ ಅದೇ sounds today. Potential difference concept, voltage, electromotive force, internal resistance, outside resistance. Ittana parameters. We have some many parameters in case of this electricity. Clear? But you should know how to differentiate each and every parameter. Simple parameters, but large. Now students, I will teach you cells in series and parallel combination. So previously we discussed about the resistors in series and resistors in parallel. Similarly, how far the cells in series and parallel are connected? If so, how we can deal or how can we add or subtract the values? So first I will discuss the cells connected in series. So I have taken here two cells, 1 and 2, cell 1 and cell 2, with E1 and E2 represent the voltage of the cell, R1 and R2 represent the internal resistance of the cell. So there are three nodes, A, B and C are the key points. Now, so what is the potential across AB? That is VAB. What is VAB? VBC and VAC. VAB is E1. Okay. And a current I is flowing. A current I is flowing in the cell. So that is VAB is potential at A and potential at B. That is the difference. Potential at A minus potential at B. That is VAB. It means the potential at A is the E1 is the potential at A. That is positive of E1 is connected to the A. So that is E1 minus, that is the current is flowing. Okay. So R1. What is R1? R1 is the internal resistance of the cell. So what I have told you before, in a cell, if a cell is giving out the supply, there will be some shortage due to the internal resistance of the cell. So only beyond that quantity you will be getting. So if the source voltage is E1, the drop in the source itself is IR1. R1 is the internal resistance of this cell. Clear? So E1 minus IR1 is a VAB. Similarly, VBC is E2 minus IR2. That is V of B minus V of C. Clear? Then VAC is what? VA minus VAB. Actually, VAC is VA minus VC. VA minus VC is V of A minus V of C is VAC. So I will show you how we get this. So I will add this VAC. VAB plus VAC is what? So sum of the voltages only. So VAB is VAB plus VAC. So VAC is V of A minus V of B plus V of B minus V of C. So what is V of A? V of A is what? These two terms is E1 minus IR1 plus VBC is what? E2 minus IR2. So you see the VAC is E1. I am writing in small letter. So don't write in so much of big one. E is E1, E2, you represent the EMF in very small, okay, very small like this. It is just a symbol, okay. So this is the equivalent value. So when you see that from this equation you see the equivalent resistance, okay, the equivalent voltages are getting added. When the cells are connected in series, their potential differences are getting added or summed, okay, and their internal resistance are also summed, okay. We are adding their potential differences and we are adding their internal resistances. That is the logic here. This equation shows that. There is a statement behind this equation. I will read the statements very clearly. The equivalent EMF of series combination of n cells, this is just for 2 cells. If we have n number of cells, 3, 4, 5, 6, the equivalent EMF of series combination of n cells is just the sum of their individual EMF. So individually you can add. So if we have 5 cells and this is no positive, negative, provided the negative should be added to positive of next cell. Okay, that is the constraint. பாசிட்டிவ் நெகட்டிவ் கனெக்ட் பண்ணிட்டே போனா என்ன ஆகும், டோட்டல் வோல்டேஜ் என்ன எல்லாத்தையும் ஆட் பண்ணா you will get total. ஓகே, ஸோ இப்போ வால் கிளாக்ல 2 செல் போடணும்னா செல் பேட்டரியில ரிமோட் கண்ட்ரோல்ல 2 பேட்டரி இருக்கு. ஒரு பேட்டரியோட பாசிட்டிவ் நெகட்டிவ், ஒரு பேட்டரியோட நெகட்டிவ் எடுத்து பாசிட்டிவ்ல இன்னொரு பேட்டரியில கனெக்ட் பண்ணா டோட்டல் வோல்டேஜ் என்ன 1.5 plus 1.5 you will get 3 volts. So remote you need a 3 volts. What you are doing here, you are adding the potential. Then if the voltages, if the EMF are EMF in a battery என்ன பண்றா இப்படி கனெக்ட் பண்ணிட்டு ஆட் பண்ணிக்கலாம். Now for this constraint you can add, if not this is E1, this is E2. If the condition is like this, how will you add? You have to add in this manner. Got it? E2 க்கு negative sign போட்டு add பண்ணணும். You have to apply negative sign for the E2 because current is coming here. Okay? Okay, sorry. Direction of current ரெண்டுமே ஒரே மாதிரி இருந்துச்சுன்னா you can add. Direction of current opposite இருந்தா what you have to do? You have to do like this. And the constant here is E1 is greater than E2. அப்ப ஈக்குவேஷன் என்ன ஆகும்? E2 க்கு பதிலா ஓகே I'm showing the circuit. So நீங்க மைனஸ் E2 தான் போடணும். ஓகே, ஏன்னா டோட்டலா பார்க்கும்போது the current direction is opposite. So please copy down this carefully. I repeat the concept. So here I have added 2 cells in series. Now I will check how these 2 cells will be adding the potential difference and the internal resistance. The potential difference and internal resistance I will add now I am going to show you. So the total potential difference is across only A and C. எப்படி resistance க்கு பார்க்கறோமோ அதே மாதிரி தான் செல்லுவோம். So the total potential difference என்னன்னா VAC க்கு VA minus VB அதாவது VAB plus VAC. இது ரெண்டையும் இந்த ரெண்டையும் சேர்த்தாலே நமக்கு VAC. அப்ப VAB ங்கிறது நம்ம ஏற்கனவே டிஃபைன் பண்ணிருக்கோம். ஓகே, so E1 minus I1 R1 E2 minus I2 R2. The same thing அப்ப இண்டிவிஜுவலா EMI ஃபைல் தனியா ஆட் பண்ணிக்கிறேன். That is EMF separately I have added and the resistance I have added separately. So this means the total EMF minus the loss. The loss ne vechukalam. Okay, the loss in the cells la drop ஆகுது போக எனக்கு வெளியில வருது output. Okay, so that is a இதுல ஒரு in case if any of the cell is in oppositely connected, இது plus minus to plus. In case if this பிளஸ் பதிலா மைனஸ் போட்டா போதும். ஏன்னா நீங்க ஏசின்னு பாக்குறீங்க, இங்க இருந்து நீங்க பாக்குறீங்க, சிபின்னு பாக்குறதுக்கும் பிசின்னு பாக்குறதுக்கும் வேற. கிளியர்? நிறைய கன்ஃபியூஷன் வரும், ரொம்ப தெளிவா சொல்லிடுறேன். பிசின்னு பார்க்கும்போது பி கூட பாசிட்டிவ் கனெக்ட் ஆயிருச்சுன்னா அது பாசிட்டிவ் வச்சுக்கோங்க, நெகட்டிவ் கனெக்ட் ஆயிருச்சுன்னா எழுதும்போது நெகட்டிவ் போட்டு அந்த ஈக்கு போட்டுருங்க. ஓகே, ப்ரீவியஸா எப்படி இருந்தது, இப்படி இருந்தது. அப்ப இது E2, VBC equal to E2. Okay, in case if the circuit is like this, இப்போ VBC னா என்ன பண்றோம்னா BC க்கு B க்கு எது கனெக்ட் ஆயிருக்கு, நெகட்டிவ் தான் கனெக்ட் ஆயிருக்கு, நெகட்டிவ் ஆஃப் E2. ஓகே, that is the main thing. polarity la da main எல்லாரும் mistake பண்றாங்க. So be cautious in making the polarity la எப்பவுமே mistake பண்ணாதீங்க. Next I will teach you how to find the equivalent value of the cells when they are connected in parallel. So this is the series combination. Next one is a parallel combination of cells. How the cells are connected in parallel. Parallel connect பண்ணா என்ன ஆகும்? This is a parallel combination. Okay. So in the cell E1 cell எப்படி direction போட்டுருக்காங்க? Okay. A C எப்பவுமே பாசிட்டிவ்ல இருந்து கரண்ட் அவுட்புட் வர மாதிரி பாத்துக்கணும். ஓகே, R1 into R2. B1 B2 ரெண்டு connections இருக்கிற மாதிரி consider. So now what is the concept here? So B1 the current I is leading I1 I2. So I will split out this current I is getting splitted as I1 and I2. So I is I1 plus I2. Now the voltage across B1 and B2, that is voltage. Let us consider the voltage at between these 2 points. Okay, between these 2 points is B is the voltage. Okay, so this B is voltage at B1 and minus voltage at B2. So how can we write this? The voltage at this point is, that is E1. That is the cell 1 minus I times R1. Okay, at this point the current is flowing here. Very practical example I am telling you is, let us consider a vehicle. Let us consider a vehicle with a petrol tank. So we have a part in a petrol tank as a reserve. Okay, reserve. So though if I fill 20 liters of petrol, if the capacity of the petrol tank is 20 liters, there may be a 3 liters, for example, a 3 liters will be withheld by the petrol tank itself for reserve. Okay, and 3 liters of petrol will be there in the petrol tank itself and it will not be given to the engine. Only 17 liters will be to the maximum given to the engine for the movement of the vehicle. Okay, or the execution of the engine. field it does is that you call it as a reserve part. Okay, so the maximum capacity is 20 and 3 is being withheld by the petrol. That is this is an analogous example. Okay, so in that way you think. So the maximum value that it can be V is the maximum value or not. E1 is the maximum value. E1 is the maximum value, but some voltage will be what? Some voltage will be what? It is being lost in the cell itself. That is a drop in voltage in the cell itself due to the resistance of the cell itself. So that is the part occurring here, IR1. So the total voltage is the generated minus the drop voltage. So even is the generated voltage of the, it is not generated. If we go for a generated, we can tell it is a generated voltage. But here it is a voltage between the 2 points. That is the actual voltage, available voltage. That is the available voltage for a cell. Then, now to take the points, this same voltage V, this V is the same voltage that is applicable for this E2. Since these two are in parallel, the voltages are same. As per the theory, in parallel the voltages are same. So since this same voltage is available, so V is E2 minus, sorry, this is I1 actually. I1 is the current flowing, not I2 times R2. Okay, I1 R1 here, I2 R2. Okay, due to this. So now I can equate these two equations. I can relate these two equations because both are equal. Now I is I1 plus I2. I is I1 plus I2. Now, what is I1? From this equation, there is, I will give this name 2 and 3. From 1, what is I1? From 1, please, it will be very better for you if you follow this. If you follow this, it will be very better for you. Okay. So you write in proper sequence with your pen and paper with my video. So from 1, first equation, I1 is I1 R1 is E1 minus B. I1 is E1 minus B by R1. Similarly, I2 is, what is I2? E2 minus V by R2. Now I will substitute the values of I1 and I2 in third equation from 3. I is I1 plus I2, which is I is E1 minus V by R1 plus E2 minus V by R2. Now I have voltage terms in both the, okay, in this expression I have voltage terms also. Now I will separate the voltage terms. So I equal to E1 by R1 minus V by R1 plus E2 by R2 minus V2 by V by R2. Then I is V1 by R1 plus V2 by R2. Okay. These are all the separate constraints. Yeah, please write in parallel, students. Next one is, this is V, voltage not R. Be clear. Always do not forget to write the voltage as capital V. Don't write it in small v. Okay. So it may confuse you. So write in capital V. This is V. Plus. So that is the minus V times 1 by R1 plus 1 by R2. Have you copied? Now, so this is I equal to E1 R2 plus E2 R1 by R1 R2 minus V into R1 plus R2 by R1 R2. So both the terms here that are common are so now I have related the voltage and current expression. So this is the equivalent value of the resistance. This shows the equivalent value of the internal resistance as if two resistors are connected in parallel. Further, to relate, I can interchange the values voltage and current to left and right hand sides to get the final expression. The final expression, if you derive it, you get it. So voltage is, how to relate this? Voltage is E1 R2. What is that? E2 R1 plus E2 R1 divided by R1 plus R2 negative of I into R1 R2 by R1 plus R2. So this is after interchanging the values, I got this. Yeah. So I into R1 R2 by R1 plus R2. So this is the final expression. And this is the equivalent, this shows the equivalent value of what the voltage. This is the equivalent value of the EMF and this is the equivalent value of the internal resistance. So this is as a parallel resistance R1 R2 by R1 plus R2, that is R equivalent. This is the equivalent value of the internal, this is equivalent value of the EMF. So this gives V is E equivalent plus minus I into R equivalent. Now I will write it clearly. The voltage is E equivalent minus I into R equivalent. So do not directly copy the final expression. You please work down step by step. So I have expanded in an elaborated way. So you do it in step by step manner. So you pause your video and then copy the steps very clearly. It is a very simple mathematics, not so much of maths, just altering the addition and subtraction and cross multiplication only. So do not get frustrated when you see directly. You can just start from here and end up with simple one. So again, I will erase this and you see follow that. I will take the equivalent values. What is this? E equivalent is E1 R2 plus E2 R1 by R1 plus R2. Then what is R equivalent? R equivalent is what? R equivalent is R1 R2 by R1 plus R2. So when you take ratio of these two, E equivalent by R equivalent, when you get ratio of these two, so E1 R2 plus E2 R1 divided by, these two will get cancelled out, R1 R2, which is E1 by R1 plus E2 by R2. So E equivalent by R equivalent is E1 by R1 plus E2 by R2. This is another formula. So this expressions can be easily expanded if we have 3 to 4 cells also in parallel. So copy it carefully, students.